Okay, so basically this is where we ended up with from last time. Basically, so far we talked about how you can use extends, how you can use super, and also polymorphism, dynamic binding, cast, right, and instance of. That's basically what we have talked about so far. Okay, study the slides and then come to the review session to ask questions. But now I'm going to go a little bit further. Okay, basically today I want to go over three things, okay, but one at a time. Let me come back to this particular example where we left off from Wednesday quickly, okay? So now let's say this. We have a class called Student Management System. The intention is we want to store two kinds of students, either resident students or non-resident students. And remember, we have the inheritance hierarchy where students is a superclass of both resident and non-resident, okay? Now we do have inheritance. Let's see how inheritance can help us. There's going to be a single array, just a single one. However, you can store dynamically either resident or non-resident students. That's the final outcome. But let's see how it's going to happen. The most important thing is, let me just go back to iPad here. The most important thing is for you to realize when we make this particular declaration over here, we say that SS over here is an array of students. So what this means, so the first question I gave you here, what would be the static type for SS at position 0, at position 1, and all the way until the last position? Well, students. Okay, very easy. Okay, so the answer is students. Let's get it straight. And then the question I asked you before the end of Wednesday's class was, let's just talk about this particular line over here. We have a method called add_rs, meaning add resident students. And over here, we declare a parameter input variable. Statically, it is resident students. And then I ask you about whether this particular assignment will be valid. Okay? And the answer is yes, because, let's see very quickly. SS at position C. C is basically like a number of number of students, like a counter. Okay? We talked about the programming pattern throughout. It's assigned to RS. Again, if you want to judge whether things compile or not, you only look at the static type. Okay, let's look at that very quickly, and then we can move on. For RS, the static type is, you can see it's declared exactly over here. So that would be resident students. And what about the static type for SS at a particular position? It will be students. Okay. So now we ask if resident students can fulfill all the expectation for students. Yes. Okay, so that compiles. And similarly, okay, I wouldn't go into the reasoning again, but you can see we got another one called add_NRS. And now the only change is parameter is called NRS. Statically, it has the type non-resident students. And now the same question. Will this line compile? It would, for the same reason. Okay, very quickly. NRS was declared to be a non-resident students, NRS. SSC, the static type, remains to be students. Is NRS a descendant class of students? Yes. Okay, so this line also compiles. And do one more. And then add students over here, adding student over here. So now you can see S over here statically is students. SSC, static type, is still students. Is students a descendant class of students? Yes. Okay? So you can see, let me summarize what we have seen to make it clean. Okay, let me have a new page. Basically, what we have seen is as follows. In this particular student management system class, the static type for every element in the array is students. So that means when you declare the parameter type over here, as long as it is one of the descendant classes of students, which is static type of the array, we can definitely take that particular variable and then store that into the array. Guys, are we okay? Let me say that again. Statically, each element of SS is students. What can we assign to a student's objects? If the student is a static type of the left-hand side, what can be on the right-hand side? Any of the descendant classes, right? And now the right-hand side is basically the parameter. It's either RS over here, NRS over here, or S over here. It would be okay compilation-wise as long as the type of the right-hand side parameter is a descending class of students. So of course, that includes students, resident student, and non-resident students. That's all you need to know for now. Any questions? This is actually very powerful. Okay, I'm going to trace the code together with you to give you runtime intuition. But just having this, so that simply means we have a single array. Each element statically is students. However, let's say line number 3 and line number 4, we are somehow able to pass some resident students or non-resident students and store them into the array. So now we can really have a mix of different types of students. That's how you can see intuitively for now. Let's go a little bit further. Okay, I want to check a little bit more things with you, and then we can trace the code. So that what I want to do now is to see how things might work. Okay, let's go over a little bit slides. Okay, that's what we said. You know, for line number 3, for example, this will be valid. And then, now what I want to remind you about, remember call by value, right? Call by value simply means, for example, if I'm trying to make a method call sms.addRSO, okay, let me just show that to you. Okay, what I really meant to say is this. Okay, let's say I have a student management system. Student management system, I'll call that SMS. It's assigned to new student management system, empty to begin with. And then I say SMS dot add, for example. If I say add rs, let's say somehow I have an object called O, just say, for example, right? According to call by value, that means I'm going to make a copy of the reference of O, right? That's what I would do, okay? And then I'm calling this particular method over here add rs, okay? So what's really happening over here is as follows. What's happening over here is rs, which is what the method is referring to over here, right? So the only thing I have to do implicitly is to say rs, which is a parameter over here, is implicitly assigned to O. So you can think about if O is currently pointing to some objects of certain type, okay? And then when I say the parameter rs is just going to be assigned to the same address value as O. So rs is also going to point to this particular object. That's call by value. Okay, if you have a problem, please review the call by value lecture. Okay, so this is exactly how we're going to see how things will work. Just add a little bit more complication about inheritance. This part is just about call by value. I want to make sure you're comfortable. Okay, whatever argument O you're passing, you're basically saying parameter implicitly is assigned to the arguments. Okay, so now let's do exercise together. I will do the first one with you, and the rest will be similar. Okay. Again, let's have the setup. So now we only talk about compilation. So there's no need to trace any code just yet, just about compilation. So that means all you got to focus on will be static type. Okay. Let's do the following. Let's say we got S1, we got S2, we got S3, we got RS, we got NRS. Okay. Of course, these are their corresponding static types. You don't have to worry about, guys, you don't have to worry about things like here because they're dynamic types. They're not relevant to the discussion right now. Okay, let me just undo it. Only have to worry about the highlighted part. Let's look at the first one. Okay, let's focus on that. And for that one, I'm going to explain in details. Let's focus on this guy over here. When we say sms.addRs S1, think a little bit. Okay, I'll pause here. All I want to know is whether this line, a method call, should it compile? For this one here, I'll give you a little bit hints. Number one, you have to know how call by value work, number one. Number two, you have to know which method is being called and what is the static type of the parameter that's being expected. So these are the two hints for you. Call by value and the static type of the parameter for addRs, which is the method we're calling. Given these two pieces of information, would you believe that this line is going to compile? Anybody want to speak up if you believe no? I heard no? Yes, why not?
Because the parameter S1
Yeah, that's exactly right. Perfect. Okay, except that when you say S1 there, it's not called parameter, it's called arguments. That's the only part. Okay, otherwise perfect. Okay, let me just repeat what you just said. Okay, for the first one, let's be very careful. Okay. Again, let's be very precise over here. S1 over here is so-called arguments. And then the static type is students. And we're calling add rs, which is over here. And rs over here is the parameter. And the static type is simply resident students. So now we got all the information we need. The only one that one more step is to think about call by value. What a call by value would do is when you're calling this method here, it's going to say rs implicitly is assigned to the argument s1. So now, is this assignment valid? Apparently it's not, because s1 has the static type students. Can student fulfill the static type for rs, which is resident students? No, it cannot, because for example, premium rate cannot be supported, right? So this will not compile. Oops, sorry. So this will not compile, okay? Let me write down the reason very quickly, just for the first one. Not compile because static type of S1, which is the arguments, is not a descendant of the static type of, over here, rs, okay, which is parameter. Okay, that's the complete answer. Having this in mind, can we just have a look at a few of them? Okay, you can see I block them out. Okay. Why don't you tell me? Okay, let's go over one by one. What if I say over here, SMS.addRs S2? Should it compile? But it's pointing to your resident students. Exactly. Dynamic type is not relevant here. Okay? So this one here is not going to compile simply because you can see statically we're still talking about students. So it doesn't make a difference. What about the third one over there? Okay? This one similarly, also we talk about student over here. Doesn't matter what dynamic type is. Doesn't matter. Okay? It's not relevant. Okay, what about the next one? Would that be okay? It would be okay, right? Because, simply because you can see RS right now, the static type is resident students, which matches or is a descendant of what's being expected. Okay? You can get a feel? Okay, so now, let's go on a little bit further. Oh, actually, just one more. What about this guy here? Oh, you said no already. Okay, good. So now you can see NRS statically is non-resident students, which is not a descendant class of resident students, right? Good. Yeah, pretty much get the idea. So far you can see that's like that. Now, for the rest of the method call, do they have the same answer? Thinking this way, I can talk about all of them at one go. What is the parameter type for add students? Students. Student is basically the root of the hierarchy for students. So that means as long as the actual argument has the static type being a descendant of parameter type students, then you'll be okay. Is that the case? Yes. Okay. So now let's see this. Okay. Basically what I'm saying is like this. First of all, when you see the slides, it's going to be all yes. Okay. The reason is because over here, if you think about S1, all the arguments over here, their static type over here are simply just descendants of the static type of add students, which is students. Of the parameter of add students, which is students. Okay, so they're all fine. So what does this tell us? This tells us that when you actually call either add rs or add nrs, because the parameter type statically does not have all the classes as descendants, so you have some restriction. So you may have compilation error, like what we have shown. However, if you simply call the add students method over there, that one, their parameter type student is very accommodating. It's basically the top of the root. So that one can allow all the descendant classes of students. So that will effectively achieve what we want to achieve. Yes, question? Oh, when I say cross over here, I simply meant compilation error. So I will really encourage you, I don't really provide the code, but I will encourage you to really try this, to actually say add rs and add a student to try if they really don't compile or compile. Okay? So again, that's good. So to clarify, when I say cross or check over here, compilation. Okay. Guys, any questions so far? Okay. Let me summarize what we have achieved, if that's clear to you. What we have achieved so far is since like line number 5 declares a method as students whose parameter type statically has students, which can accept any arguments, because it's called by value, any argument whose static type is a descendant of students. So by using as students, we can basically add so many things into the array of students. So now we want to see exactly what's going to happen. Okay, that's what we're going to see. Okay, so now let's go back to the slides. Okay, this has been covered. You can also just read through, just to double check. Okay, that's exactly what we have just gone over. Okay, it's been done already. So now, before I actually go for runtime, I want to do one more thing. Okay, we still talk about compilation. Okay, let's talk about casting. Okay. For that one, I'm going to go over a series of examples over here. For the first one, let me show you the slides quickly, and I'll go to iPad. Can we have a look at this fragment of code? What we are doing is, line number 1, we create a students objects. Dynamically, it's also students, dynamically. So static type and dynamic type are the same, which is OK. And you can see line number 2, that's the comments for you. Line number 3, we create an empty student management system. And then for line number 4, can we agree that it's not going to compile? Simply because the argument S in line number 4 has a static type students. And add rs is expecting a resident students. Student is not a descending class of resident students, so that wouldn't compile. Okay? Now, what if we really, really want to make it compile? Is it possible to do either an upward casting or downward casting to actually make this happen? I'm talking about line number 4. I'm playing with the cast a little bit. Is it possible? So add rs is basically expecting a resident students. Can I somehow cast s into resident students? Yes, I can. That's a downward casting, right? So why don't we try that quickly? Okay. So what I would do is, that's kind of the flavor of the next 3 or 4 examples. Okay, I'm going to just go for iPad to present to you all at one go, so you can see exactly what's happening here. Okay, so for now, we're only going to look at this guy over here, just this guy here. So we know that this guy here is not going to compile, simply because, let me just remind you very quickly, okay? Because this add rs basically is expecting resident students, rs, just remind you. Okay, that's a declaration. Okay, so now when you say sms.addRs is not going to compile, okay, similarly, let's say we still have another student variable here. Dynamically, it's non-resident students, but this will still not compile because dynamic type doesn't matter. Okay, so it still does not compile. The next one over here, we have also statically s as students. And when we say add rs, s still doesn't compile. Okay, so far so good. Now we want to know how we can just to make it compile. What I will do is, let me clear this a little bit, and then I'll do the change for you. Okay. The change I want to have, let me write, is already written down here. Originally, I say add rs and then s. But now, remember anonymous cast? we don't have to assign any temporary variable to the cast version. We can simply say S cast with resident students. So this is the expression I can write, anonymous cast, okay? So what would be the static type for this particular anonymous cast? Resident students, right? First of all, this is a valid cast. Specifically, it's a valid downward cast. It's a downward cast simply because S was declared to be students, and we're casting the resident students, okay? With static type resident students. Okay, so now what I would do is like this. Rather than, let's get rid of this, okay? So now I'm going to change the code a little bit. So now, rather than having S over here, I'm going to write resident students. Yes. Now, is the method call going to compile? It is, right? Okay. For those of you who don't quite see, I would like to just spend a little bit more time. Okay, I want to make sure you're really comfortable with this. What we have over here is SMS dot add RS. And then we're doing a cast. Resident students. And then over here we have S. Okay, put everything into context. We declare students S over here, which is assigned to new something. Dynamic type is not relevant, okay? And also, we have in the student management system class, we also have this particular method, right? When you have class, student management system, and one of the method was void add RS. And then that one is the resident students, RS. Okay, let me just make sure everything is here for you to consider. Our question is whether this particular method call is going to compile. Okay, the answer is it will. Okay, let's see in detail. Number one, this particular cast over here, this is a valid downcast, as we explained already, with static type resident students. So now, in order to see whether this particular method call with this particular cast version, is it going to compile? It will be, because RS, the cast version static type, is now a descending class of the parameter type over here. It is. So now it will compile. Guys, any question? Anything that's not clear, it's now time to speak up, please. We only talk about compilation, not think about whether there will be a class cast exception just yet. We will, but not yet. We okay? All right, I assume you're okay. So now for the similar reason, okay, this will check. Similarly, if I also change this guy over here also to resident students S, okay, the same reason, it will also be a check. It's also a downcast because now S is also statically students. Dynamically, it doesn't matter, okay? One more thing before we talk about runtime. And this guy over here also, if you cast that into RS and S, that will also compile because statically S is still students. Now, let's switch our context to runtime, which means you have to consider also the dynamic type. Let me number them. So now we basically got 3 method call with the cast that all compile. Let me call this guy here number 1. Let me call this guy over here number 2. Let me call this guy over here number 3. Let's talk one by one. When I execute number 1, it compiles so I can execute it. Am I going to get class cast exception? I heard yes. Anybody who think that's no? It's okay. Think about it. Think about when will you get a class exception? You will get a class exception when you are trying to do a downcast too much. so that the class type you're trying to cast into cannot be fulfilled by the dynamic type. So now, for number one here, dynamic type is actually a students. And we are casting that into resident students. Can this dynamic type students fulfill expectation on resident students? No, right? Okay, so that will be class cast exception. I'll write this down. What's going to happen is, it's going to be class cast exception. Yes, for this one, yes. Because the dynamic type, which is students, cannot fulfill the class type, the cast type over here, RS expectation. What you could have done is to say, before I try to do this particular one, let me say, over here, what you could have done is like this. Let me write it down. What you should have done is like this. Is have some instance of check to make sure before I cast S into RS, I'll make sure its dynamic type can really fulfill the expectation instance of. So I would say if S instance of, I want to cast into RS, so I say RS over here. And then if it is the case at the runtime, okay, and then I would say SMS dot at RS, and then I can do a cast. Okay, so now again, instance of is whether dynamic type of S can fulfill expectation of RS. That's just another further extension, right? Every time you want to do a cast, if you're not exactly sure, you better do an instance of check to make sure it's going to be fine at the runtime. Okay, that's how you can avoid class cast exception at the runtime. Okay, let's do a little bit further. Okay, what about this guy here? Let's talk about line number 2. Are we going to get class cast exception for number 2? We are. Okay. Can anybody explain to me why we will get class cast exception? Apparently, it's a downward casting, right? So that's they compiled. But why would we get a class cast exception? Anybody? Want to try? Yeah? Yes. Go ahead. Exactly right. Very good. It's simply because dynamic type of S, which is over here, okay, that's the dynamic type. It cannot fulfill the expectation for the cast type RS. Okay, cannot fulfill. Okay, so yes. Another one, how about number 3 over here? Are we going to get a class cast exception? We know, right? Okay, now this one I can just tell you. Because dynamic type for S over here is resident students over here. And then resident students dynamically can satisfy all the expectation of RS. Because RS is a descending class of RS itself. So that's okay. Okay? So this can fulfill. Okay, so this is no. There will be no class cast exception. So now, guys, let's have a look at one more thing. Right? I already talked about 3 slides. Okay? So I just want to talk about all at one go so you can see the clear picture of what I'm doing. I would like you to look at this fragment of code again. Again, pretty much similar. So now let's say I have a static type non-resident students, NRS. Dynamically it's this, okay? And then apparently if you say add RS and then NRS, it wouldn't compile because static type resident students doesn't match the RS that's expected, right? First of all, okay? So now the question is, what's going to happen if I change this guy over here into, okay, I'll write it at the top over here, into resident students NRS. That's what I will do. Okay, let's say, and now we're going to consider. Are we going to run into a class cast exception? Or this question simply doesn't make sense? It wouldn't even compile. Why would you think that's the case? Exactly right. Okay, so this example here, it's not really tricky because everything, you just want to think about if the cast itself is actually makes sense. Okay, so now think about this. Basically, we're talking about this guy here, just about this particular cast over here. This particular cast, NRS static type is non-resident students. And then you're casting NRS into resident students. Simply not good. Because again, if you think about the hierarchy, students, and then resident students, non-resident students, you're basically casting from NRS over here into resident students, which is over here. It's neither upward nor downward casting. So it doesn't even compile. Okay. Okay, so now, no, it doesn't compile. So you cannot even see if there will be a class cast exception. You just cannot execute it. Guys, any questions about this before we see some code tracing? Yeah, so basically you can see you just go one step further. In order to really master today's topic, you just have to know how call by value work. And everything else has been covered already. You just have to apply what you have known so far. Okay. Any questions before I move on? Okay. The next important thing is to see how things work at runtime. And then we have to do a little bit exercise at runtime. Okay, let me, I'll come back here a little bit later. Okay, we have already covered the 4 examples, in that particular single slide, so we don't have to worry. You can just read the slides when you study, but they should all make sense now. Okay, again, that's what you should do in order to avoid class cast exception, right? Instance off. Okay, I already covered that. Okay, so all the 4 examples. Okay, so now I would like to talk about polymorphic collection. Okay, so what I meant by polymorphic collection was this. Collection can be a primitive array, which is the example I'm going to show you, or it can be an array list, it can be a linked list, can be anything like a collection. When I say it's polymorphic, simply means the type, the static type for every element in the collection is somehow an ancestor. However, dynamically, the runtime types can be any of the descending classes of that particular element type statically, right? That's kind of what polymorphic really means. But we're going to see exactly this can happen. Okay? Let's go over a little bit code on the slide, and then I'll switch to iPad. So let's say we got a student management system here, and then we have an array. Every element in the array statically is a student. Okay? And then we got as students over here. Well, let's say we keep this guy here, right? So as we said before, as students over here is very accommodating because when you pass arguments, the argument static type can be any of the descending classes of students, right? As we said. And then when we can say register all, and over here, students I, and position I will just get register. Okay, I'll talk about what it means in just a moment. And just to remind you very quickly, when you study the notes, you can also click on the link over here. This will bring you back to what if you don't have inheritance. With inheritance, you have a single array just for students, where you can store so many, both kinds of students. That will bring you back very quickly. If you go back to no inheritance case, that's what you have to do, right? Resident student and non-resident student, because they have nothing to do with each other. Okay, let's switch back. That's a nice comparison. Okay, let me go back there. Okay, that's the code we just went over. So now, what I'd like to do, run some little bit test cases with you. Okay. Good. Let's see exactly how things are going to happen, okay? Let me just go back to iPad and then illustrate the test case for you. Okay, let's go line by line. Line number 1, we're going to create a RS over here. Dynamically, it's simply just going to be resident students, okay? This basically corresponds to this particular resident students over here, right? You can see RS is pointing to a resident students objects, and Rachel, as you can see, Rachel over here. And then in the beginning, of course, eventually we're going to register some course for Rachel. Okay, that's how we start with. And then we set a premium rates for RS to be 1.5, which is here. Okay, so far so good. Okay, and then we're going to talk about another variable, NRS. Okay, non-resident students NRS. Dynamically, it's also going to be a non-resident student, Nancy. And then set the discount rate to be 0.5. So NRS is over here. It's now pointing to this particular non-resident student's objects, and we set a discount rate to be 0.5. So we got two different objects, basically, dynamically. And now we created a student management system objects, SMS. The most important two lines are these two lines over here. SMS.addStudents and SMS.addStudents. So now what's going to happen over here is really important. Okay? Line number 6 and line number 7 are calling the same method over there. Okay? If I just remind you very quickly about this guy here. When we talk about addStudents over here, okay? addStudents Okay, let me move this a little bit to the left so I got more space. Oops. Students, and also I have students over here, S. I'll say SS at position counter is assigned to S, and then counter plus plus. That's what you can see from the previous slides, okay? I'm just repeating it. So now we want to see exactly how this line over here is going to be executed. That's what we want to see. When we execute line number 6, what we're going to have is this. We're going to have something here. We're going to say SS at position 0. To begin with, it should be position 0 that we should store. Is assigned to, so now you can see RS over here because of call by value. So RS is now going to replace to be over here, right? So now it's assigned to RS. So that means SS at position 0 is now going to assign to S. Okay, that's the first one. Okay. That's the first one. What about, and of course after this, you're going to increment the counter to 1. Okay, 1. But I'm just showing 2 for the eventual result. Okay. So after this, of course, you're going to increment the counter by 1. So now, what's going to happen when we try to execute this for the second time? So now we're going to say addStudents and then NRS. So when we execute this for the second time, it's going to be something like SS at position 1 is assigned to, so now the argument is NRS because of call by value, so now it's going to be NRS, right? The same method. So now it's assigned to NRS. So what this will do is it's going to say at position 1 for the SMS array, SS over here, is now going to point to this particular objects. Guys, are you following so far? Okay. If you're lost, please let me know. Otherwise, I'm going to go on. What's happening here is like this. Let's see what we know before I go further. Students, that should be SS, sorry. Okay, that's the array we're talking about. Statically, every element is of type students. However, after the whole setup, after line number 6 and line number 7, static type for every element in the students array remain to be students statically. However, dynamically, position 0 is pointing to a resident students object, so that's a dynamic type. And then position 1 is now pointing to an object with a different dynamic type. More precisely, what if I do the following, okay? And test your knowledge quickly. SMS dot. Actually, the exercise is exactly over here. I'll go back to there. It's the same diagram, okay? I just got things set up already here. Can we consider the checks over here? Can you actually see it at the bottom? Okay, I want to make sure you can see it. So now I'm saying I'm doing 3 instances of checks. SMS at position 0, SMS.ss at position 0, and I'm basically talking about position 0. I'm talking about this object specifically. When I say instance of, I'm basically asking whether the first elements in the SS array, can it dynamically fulfill the expectation of, for example, non-resident students? Can it? It cannot, because if you trace the code, dynamically it is. Dynamic type over here is resident students. We're basically asking, can resident students fulfill non-resident students' expectation? No. So this will be false. It compiles by just false. And then what about this guy here? It'll be true, right? Because it can fulfill, of course. True. How about this? True, right? Because students is an ancestor class of the dynamic type. Of course, it can fulfill. A little better? Okay, let's do one more. Okay. Now I simply change the left-hand side operand for the instance of. It's now SMS SS1. Is it of a different dynamic type or the same dynamic type? It's a different one, right? You can see at position 1, basically it's now pointing to a non-resident students. Let me write it down. Dynamic type is right now non-resident students. Asking the same question. Can this particular dynamic type at this point, can it fulfill non-resident students? Yes, you can see true versus false of a different position, right? And also, how about this guy here? False, right? Because NRS dynamically cannot fulfill resident students. And finally, how about this guy here? True. So now you can see for the different checks, you can see specifically, this is true, false, this is false, true. Simply means dynamically, these 2 elements are different types, dynamically. But statically, they are still students. Now, is any question here? Okay. Another quick check for you. I know that dynamically, I'm pointing to resident students from position 0. Can I say something like this? SMS dot SS. Okay, SMS is over here. SS is the array. I want to go to position 0. I know that dynamically it's a resident students. Dot set premium rates 1.25. Can I do that? Would it compile? Well, if to judge whether it compiles or not, you only consider static type. Agree? What's the static type of the context object here? Right? Again, you got to be very careful whether it's compilation or runtime. Instance of check is more like a runtime checks. But now if you look at this guy here, first of all, you can see it's a dot notation over here, okay? So this is the context objects over here, okay? Static type is what? Students, because you can see it was declared to be a student, right? So any position should be students. Although dynamic type, I'll write it down anyway, dynamic type is resident students. Now I'm only asking about compilation. So that means I don't even have to consider dynamic type. Does student class support set premium rates? No. Does not compile. So you got to be very careful. That's why I try to mislead you a little bit over here, just to make sure. Even though dynamically position 0 is really pointing to a resident student class. True. However, when you say SMS SS0, compiler doesn't keep track of dynamic type. They only look at what's declared statically for every element, which is students, and it does not support set premium rate, so it does not compile. Okay? Wow. Questions? You still got time before the written test. That's okay. So that's why you want to think about this. Okay, let's go back to the original one. I want to go through a little bit more method tracing with you, but you pretty much get the idea, right? About instance of and also statically, things like that. On the other hand, can I say things like, this one we know it wouldn't compile. What about this? SMS dot SS position 0 dot register. Let's assume EECS2030 is a course object. Let's assume, okay? Would this compile? So to judge whether this compiles, you have to know whether register method is declared in the static type students, right? Let me write it down, and I'll show you the hierarchy. Again, this guy over here, we know that the static type is students. It will only compile if register is declared in the student class. Is it? It is. If you recall this particular hierarchy here, student class indeed declares register. It's a common method for every descendants. Okay, that's why it will compile. Okay, so when you study that, you can see. Okay. Of course, every time you want to refer to the hierarchy that's in question. Okay. All right, let's go back here. Let's trace a little bit code. Okay. So now what I would like to do is continue a little bit after line number 6 and 7. First of all, I'll do line number 8. Line number 8 over here. Let's do a different color. Number 8, I'll simply create a course called EECS2030. Okay, so that's basically EECS2030 here is a course. And then I'm going to call line number 9, which is SMS.register all 2030. Let me use a different color. That'll be better. The blue one. It's basically registering a common course for all the students in the system, let's say. So what that would do is it's going to call, so that's a student management system class, and we're calling register all method. Okay? So now let's see exactly how this is going to be executed. Okay? So now when you try to execute this particular method over here, you're going to run a loop. Because currently you can see the counter tell you there are 2 students in the system. You guys going to start from 0 until the number of students, right? That's a pattern we talk about. And then you're going to say students, again, this should be SS, okay? Just not to be confused. The array at position I could be 0, I could be 1, only 2 student objects in. And then we'll say .register. So that's something we just talked about in the previous slide that would compile, okay? So now a question for you. We agree that it's going to run in total 2 iterations, right? Because we got 2 students. For the very first iteration, it's going to say SS at position 0 dot register. And then C. What would that do? If you think about it. Should that modify this student here? Or should that modify this student here? First student or second? The first one, right? Because over here, SS at position 0 is basically SS at position 0 is now pointing to this particular resident student's objects. And resident student's objects for sure can fulfill student's expectation, which got register. You can think about resident students and non-resident student. They share the same version of the register. That one is not overridden. That's not redefined. Okay, you can refer to the previous lecture notes. Okay, so now when you call in the first iteration SS0 that register, it's simply just going to say, for this particular resident students, I'm going to assign the first course to be EECS2030. That's what you will do. What about the second iteration? The second iteration, I'm going to say SS at position 1. And then dot register. C, the course. What that would do is, so now at position 1, we got this particular non-resident student, right? So what we will do is, we're going to assign their first course over here to be EECS2030. Right? That's kind of the diagram tracing I want you to be comfortable with. So now, after OR, the consequence would be, after this, you can see for both RS and NRS, they are now classmates because they both point to the same course for them. Okay, are we okay so far? Okay, now, final thing to worry about. Resident students and non-resident students. Let's go back to hierarchy. Resident students and non-resident students, they share the same version of register. Okay, that's what we have just illustrated. What about get tuition? Do they share the same version? Not really, right? Because you can see get tuition is one version here using the premium rates. And get tuition here is another version using discount rate. So now we want to see exactly how dynamic binding is going to work. That's the final part of code we want to consider. Okay? So now we're going to consider exactly this loop over here. Okay? The loop itself is very easy, only 2 lines to consider. We're basically saying from loop counter I, starting from 0 until number of students, we got only 2 students. So only 2 iterations to worry, right? And now we simply say SMS dot, again, it should be SS, okay? Again, I'm going to change that. Dot get tuition. We know that since we got 2 students, we're going to run 2 iterations in total, right? So now, can you tell me, is the first iteration going to call the same version of get tuition as what's going to call in the second iteration? They're going to call different versions, right? Good. If you got an intuition, that's good. Let's see why. We know that I can be 0, I can be 1, okay? So for the very first iteration, we're going to get, basically, let's use blue, SMS dot students SS at position 0 dot get tuition. So this is the first iteration. The second iteration is going to say SMS dot SS position 1 dot get tuition. That's iteration 2. Okay? So now you can see get tuition here, get tuition here. They are all defined in the student class statically. So that's why they compile. But now dynamically, what's going to happen? You want to look at the context object and consider the dynamic type. So the first one over here, SMS at position, the array position 0, we are really referring to this particular objects. Agree? Okay, so now that means dynamically, this one, dynamic type is simply RS. So now, which version of get tuition are we going to call? The one that's defined in the resident students, right? So now that means you're going to call this particular version of get tuition in the resident students, simply because it's instance of resident students. Okay? So that means call the version of get tuition in resident students. That's what's going to happen. And then if you do that, it's going to apply the premium rates, 1.5. Okay? So let's say, for example, it's 500. You're going to say 500 multiplied by 1.5. That's what the get tuition will get you. Talk about very quickly. And then, what about the second iteration? For the second iteration, we're going to get SMS.SS1. Okay? Again, you're going to see over here, for this particular line, okay, I'm going to write it here. Okay? Dynamic type, so talk about 1 over here. Dynamic type is non-resident students. So now, because of dynamic binding, which get tuition are we going to call? Non-resident student over here, right? Dynamically, right? So now that one is the one that's going to apply the discount rate. Okay? So now when you call that, it's going to apply this discount rate, which is 0.5. Okay? And then there's going to be 500 multiplied by 0.5. That's what you'll have. Okay, we have traced this fragment of code very carefully. So you can see there are many things happening here. Okay, I'll summarize, and then if you got questions, I can answer. From line number 1 to line number 4. From 1 to 4, we're basically just setting up the objects over here separately. Okay, and then 6 and 7, we are creating a polymorphic array. which means the first position is pointing to A, resident students. The second position is pointing to A, non-resident students. Okay? That's creating a polymorphic array. And then line number 9 is already dynamic binding because we simply say register all the students in the array, in the student system by the common course, right? So we're going to go over the first iteration, register for this particular students into this course. And for the second iteration, go for this student dynamically non-resident students and register into this course. Okay? Finally, when we want to see the tuition, right? Again, run a loop. The first loop is going to look at resident students. Get tuition is going to call the version with the premium rates. And the second iteration is going to call on this particular non-resident students, the get tuition, which would apply discount rate. Okay? That's basically what's happening here in this example. So polymorphic array or polymorphic collection is very powerful because now you can see that you only have a single collection for all kinds of students you can have. In this case, we only got 2 kinds, but if you got more than 2 kinds, that's also fine. It will just work out. You just have to understand how the dynamic binding is really working. When you call the get tuition, depending on what the dynamic type is, you're going to call the corresponding version of get tuition. Okay? Any questions? We okay? All right, I assume you're okay. Okay, after this, okay, I think this slide here, I only meant to really talk about instance of. I already talked about it, so we are fine. Okay. So this is really about the polymorphic arguments. That's it. Right? Yes, question.
Going back to that top right there.
You mean over here?
On that slide, on the computer, on the top right of that slide there, we're doing SMS.ss as addition 0 dot set. The reason why it's I'm just not really sure why it wouldn't.
Okay. Sure, no problem.
Is it because the static type of
Exactly. Exactly.
array as
I will explain to you. Yeah, no problem. That's an important question. First of all, can we just say SMS? I'm going to write it down. SMS dot students, position 0 or position 1, doesn't matter. Okay. Premium rates and something over here. Okay. In order to determine for compilation, you only consider static type. Okay. So now let's do one by one. SMS, as we remember, SMS was declared to be Student Management System, SMS. Does SMS has an array called SS? It does, so this part is okay. Okay? And inside this particular class, okay, we actually got students array, SS, etc. So that means for this particular expression over here, we are going into particular element of the array. The compiler can only look at the static type, which means they will look at how SS was declared to be statically. In that case, it was just a students. So that means students static type is simply students. Of course, according to what we just said on the slide, on the visualization, dynamically, you might be pointing to a resident students, you might be pointing to a non-resident student. However, compiler doesn't care. It just cannot keep track of. It's an undecidable problem, right? So now, if you look at that, compiler will only say, okay, you're statically pointing to some student object or descendants objects. But now, can you actually call set premium rates? The answer is you cannot, okay? Because set premium rate is simply not declared in this type, okay? Not declared, not available. Or you can say not part of its expectation. Okay, make sense to you? Okay, good. So guys, let me have a very friendly reminder for you. When you do the written test, it's really important for you to know what each question is asking. It's asking you about compilation. If that's the case, only consider static type. If it's asking you about runtime behavior, you have to also take into consideration dynamic type. Okay, that's a principle I keep emphasizing. Okay. All right, that's about the polymorphic arguments. And we have to talk about return value to make the whole story complete. Okay, let's do that quickly. Okay, so now let's do return values. Okay, That one there is going to be similar. So now we don't have to spend that much time. But I just want to make sure you got enough information. Let's say we got student management system here, and then again we got students array, okay, the same setup. And then as students, that'll be very accommodating. Let's say we got a new accessor method. What that will do is the return type is actually a students, okay, return type. So which means statically, what the compiler will know about the return value from getStudent is it just return a students. But dynamically, it could be a resident student. It can also be a non-resident students, right? The same idea. But let's see how things happen. What the getStudent will do is, first of all, it will simply, let's say, just make it a little bit easier for you to think about. Because I know eventually I want to return something that's of type students, I'll simply declare a local variable. Eventually I'll return s, eventually. Initially just null. And then I'll say, okay, if I is not a valid index into the array, I can actually give you some exception, okay? If it is valid, I'll simply do line number 10. A very quick check by you. Is line number 10 going to compile? It will be, right? Let's do very quickly, okay? The static type for SSI will be students, as you can see from line number 2, right? Static type for S, which we declare to be a students, which matches the return type, right? Student can fulfill students, okay? So line number 10 is not a problem, compilation-wise. So now, I'll give you a little bit intuition before I get to the tracing and code. If you look at line number 10, SS is a polymorphic array, which means SS0 could be storing a dynamically can be storing a resident students objects. SS1 dynamically can be storing a non-resident students object. So now, when you return, dynamically, it can either be a resident students object or it can be a non-resident students object, right? Good. Simply because the underlying array is polymorphic. When you want to retrieve something from that, it can be anything, as long as it's the descendants of students. Let's see some example code to really get it straight. Okay, that's exactly what I just said, okay? Dynamic type for the return value can be any of the descendant classes of students. That's basically what I'm emphasizing here. But now we're going to go over some code quickly, okay? Quickly. Again, I'm going to look at a very similar setup, okay, very similar. Okay, I'll go over with you, don't worry. Oh, by the way, the diagram over here is exactly the same as before, just to make it easier, okay? It's basically the same example with a little bit extension. Again, we have these guys here. We have a course over here, 2030, okay? That's a course objects. And then we have resident students RS. We also got non-resident students NRS. And we set their premium rates and discount rate. Okay, you'll see resident students object here with the premium rates. You also get the non-resident students object here, and then you got the discount rate. Okay, very easy to set up. And then we also get student management system created. And now, what we cover in the previous example, we say sms.addStudents RS, sms.addStudents NRS. What that will do is, position 0 is going to point to resident students. Position 1 is going to point to non-resident students, right? That's what we did, okay? So now, let's understand just one line of code very carefully, okay? What I want you to understand is this guy here. I'll write it down besides, and let's analyze that. I basically say students S is assigned to SMS dot get students. And then I say 0. I'm basically calling this particular method here, okay? So now I have my first question for you. Is this line going to compile? If you believe it is going to compile, why is that? I'll give you one potential answer and tell me if that's right, okay? I would argue that this compiles simply because at position 0 of the array is currently pointing to dynamically objects of type resident students. Is that the right answer? What's wrong with this answer? I'm using dynamic type to answer the compilation question. Absolutely, that's completely wrong. Okay, so what would be the correct answer then? You mean the static type for the return value is the students? Okay, good. Okay, let's see. It will compile because, again, you have to look at both sides. If you look at this side over here, we're calling get students. Get students is here. So I pointed the wrong place. Okay, what I meant to point previously was this guy here. Okay, so now when we talk about this line, the static type is simply just the return type that we declare. Okay, that's what the compiler will look at, is students. So now, is students able to fulfill students? Of course. So compiles. Number one. Okay. Number two. What if I say SMS get students 0 instance of. Okay, it's a keyword, of course. Okay, that's a question. It's a runtime check. Would that be true or false? True, okay. Oh, by the way, if you look at the left operand of instance of, so far we have, so that can be an expression, right? It's referring to some objects. We're saying, tell me what this is what it is asking, okay? What it is asking is as follows. Tell me what the dynamic type is for this particular object over here. It's referring to position 0 of the array, right? Which is this resident students. Dynamically, is this object able to satisfy the requirement, the expectation for resident students? Yes. Okay, good. So that's going to return true. I'm pretty sure you will be able to tell me what if, hypothetically, if I change this type over here into non-resident students. True or false? False, because now I'm still talking about the same object over here, and now it's not going to fulfill non-resident students, so that'll be false. Okay, just to check. Good. Okay, that's basically the next two lines. Okay, I'll leave that to you. Basically, one more thing. When I say over here, after this particular assignment here, so S is now pointing to SMS.getStudents0, right? It's really pointing to this particular first element, okay? That's something I want you to show you, okay? It's pointing to there. So now, if I say S.getTuition, which version is it going to call? Is it going to call the version of getTuition from resident students, non-resident students, or students? Residency, right? Dynamic binding, right? Remember, okay. Okay, I'll mention that to you quickly, okay. Version of resident student, okay? Simply because dynamic type is resident student. So one more thing to tell you when you study the notes. You can see somehow I reassign S into SMS.getStudents1. So now I want to get dynamically the first elements in the array, which is pointing to this particular object. So now the dynamic type of S changes to non-resident students. So now if I ask you the same question, print S.getTuition over here, notice that this line over here, S.getTuition, is exactly the same as S.getTuition over here, exactly the same. Are both lines going to call the same version of getTuition? The answer is no, because when I call this line over here, is after I say S is assigned to SMS.getStudents0. Dynamically, S will point to resident student object, so you call a different version. On the other hand, when I call this line over here, it's actually after this particular reassignments, which is referring to position 1. And that's referring to non-resident students. So it's calling a different version. Guys, are we okay? Okay. What's the take-home message for this? This example here simply shows you for your return type, you have to know statically what the type is. In this case, students, for get students. Dynamically, you can return any objects whose type is a descendant class of students. You have to know how to trace them. In order to trace that, dynamically you have to draw objects like what I'm drawing over here, right? That's kind of the training we have been showing you, since this beginning. Okay, things get very interesting, right? You can see just a single piece of code like this, you got so many things to cover, right? Any questions? All right, I got just one final thing to talk about very briefly, okay? And then we are done. Okay, I really appreciate you coming today. Okay. All right, let me talk about one more thing. Okay, so now we are basically finishing up the topics for inheritance, but one more thing to show. But that one there, just to confirm some concept over here. Very easy. But I think if you believe you got maybe 80%, 90% of the lecture content, that's very nice. But to really do well in the written test, I would suggest you want to study the notes, example again. Try to explain to yourself why each line works the way it should work. And then ask me questions, either this afternoon, if that's not too early, or you can ask me next Friday. Okay, we have time. Okay, one more thing to say. Okay, polymorphic array. Okay, I would say this is the most important slide for today, right? That's why we spend so much time talking about it. Okay, so this one is simply remind you, whenever I ask you about whether Java code compiles, you only look at the static type. Do not worry dynamic type. If I ask you about the behavior of the runtime execution, you have to consider dynamic type. Okay, just a reminder. Okay, for this one here, this slide here is just to make it formal. You don't have to memorize it. Okay, for those of you who really want to make things precise, that's how you can think about the compilation that we talk about. Okay, for that one, I will just let you read it. But if you got questions, you can ask me also in the review. I might just mention that briefly later. Anyway, okay, I'll do that quickly. So now, basically, we want to talk about equals method quickly, but the same concept applied to toString or other methods. The slides are a little bit detailed. I want you just to get you the intuition. Okay, I'll show you right away what I really meant by that. I'm going to talk about different versions so you get exactly what I want to bring to you. The concept I want to bring to you is overridden methods, redefined methods versus dynamic binding. The story is like this. In the object class, which is the root of the inheritance hierarchy in Java, we have the equals method, which by default is simply this equals obj, right? That's what we talk about. That's the default version. Let's say we have a hierarchy like this. We got object here, we got A here, B here, and C here. C extends B, B extends A implicitly extends objects, right? Let's say this. We have, in line number 1, we declare C1 to be new C. Static type for C1 is objects. Dynamic type for C1 is C. Okay. Similarly, we also got C2 over here. Okay. And then we want to see what would be the version of equals method being called when we say C1 dot equals C2. This first example is very easy because you have no choice basically. The assumption is A does not override the equals method. B does not override the equals method. C does not either, but you can see the corresponding code here, right? That's what I'm writing here. So now, line number 3, which version are we calling? From which class? Object class, right? That's the only version you have. So that's why I said it's a no-brainer, okay? Object class, okay? Simply because that's the only version we have. Let's make things a little bit more complicated, a little bit. Let's say we have this. Let's say we have 2 versions over here. Version number 1, default version. Version number 2 is down to this particular C. Okay? So now, if I have over here, okay, you can see redefines somehow. Again, C1 dynamically is C. What's going to happen if I say C1 that equals C2? Am I going to call version number 1 or version number 2? Well, which version to call depends on what the dynamic type is, right? Dynamic type over here is C. C has this version. You got to go to the like a closest ancestor version. C is an ancestor of itself, so that's a version we have. Okay, so that one is going to call C. To emphasize that, so now what we have is this. Let's say we still have over here version number 1, version number 2. C1 dynamically is C. Now, when we say C1 that equals C2, is it going to call V1 or V2? V2, right? Because dynamic type here, closest one is V2. Okay, so that's also V2. So far, so good? Okay. I do want to give you one more example. Okay, I remember a student from last year asked me a very interesting question. Okay, I'll explain to you. That'll be the last example for today. Again, we have objects over here. Okay, we know that it has a version. It has an equals method here. I'll just say equals. We got A here. We got B here, and we got C here. Okay, let's say in A we redefine the we override the equals. Okay, in B we don't. In C we also override the equals method. Okay, basically version 1, version 2, and version 3. Okay, is it clear? What's the setup? Okay. Now let's say this. I got objects obj is assigned to dynamically B. Okay? Dynamic type is B. Okay? And then I would say another, if I say obj dot equals over here something, right? Some object as well. Okay? So now, question for you. The equals here, is it going to call V1, V2, or V3? I heard V2, okay? If that's your intuition, that's right. Because my student, they thought, somehow, you say the closest one, right? This is only one class away. This is also one class away. Why wouldn't you call V3? Remember I said the closest ancestor, okay? So now it's going to call this version over here, okay? Closest ancestor. Question here, I'll take it and then, yeah.
If you just rather than dynamic type B, if you make it C and then not have the equals method overridden in A.
So, okay, I'll answer this quickly, okay? Hypothetically, I'm going to use a different color. Hypothetically, let's say you're saying dynamic type is simply C, right? And then you don't have this guy here, right? Is that what you meant? In that case, well, you call V2. That's basically, I'm not sure if I got, oh, sorry, I didn't have the example. But again, the same principle. In this case, you only got either V1 or V2. In that case, the closest ancestor you have is this guy here. This one's closer than this, so you call V2.
Shouldn't you force it to call?
Oh, you cannot say, I want to force to jump to the further ancestor. You cannot. The principle is you call the version, when you do dynamic binding, you call the version of the method that's in the closest ancestor. Okay? Closest ancestor. Okay, guys, any questions? You okay? Okay, thank you. So if you can make it to the review session this afternoon at 4 p.m., okay, I'll see you there. Okay?